For Chapter 9, Section 5, we are going to go over how to find the inverse of a function. What an inverse function is that it's a function that undoes the action of the function that you started with. And when I say function, I mean the equation that you're working with. So you're going to be started with an equation. I'm going to show you the process that you can follow in order to help you find the inverse. And then if you were to look at the graphs of these two things, you would see that they have similar points. It's just that everything's been reflected or flipped, and so it changes it slightly. So when you're doing this process, there's just kind of some steps that you guys can follow to make this a little bit easier on you. For example, if you start with something like this, f of x equals 3x minus 9, that right now is considered to be in function notation because of that f parentheses x. So the first step I would do, and if you need to write yourself some steps, just kind of know what to follow, I would do that. Replace your f of x with a y. And you can see that that's what they did right there. F of x and y represent the same thing as far as when you're talking about the graph. So y equals 3x minus 9 is what we're looking at now. Step 2 is to switch your x and your y. So you can see now instead of it saying y equals, it says x equals. And instead of 3x minus 9, it says 3y minus 9. So that's the second step, is you want to switch where your x and your y are. They're just going to take each other's spot. Step 3, and this is probably where the bulk of the work is going to be, is you want to solve for y. So because I moved it over here by the 3, I now need to think about how am I going to get this y by itself. So the first thing that you can see they did is they added 9 over to that x. And they got this equation. X plus 9 equals 3y. Now to get the 3 away from the y, right now it's being multiplied together, so we're going to divide both sides by 3. So it looks like this. X plus 9 over 3, which you can also think of like this. You're taking the x divided by 3 and the 9 divided by 3, which some of you might like to write it like that better because then it allows you to see how they got to this answer here. And all they did is they flipped it around. They put the y first and they switched over on the other side so that it kind of matches what we had written up here. So remember, the number in front of x is a 1, so that's how they're getting 1 over 3. And then they just pulled the x to the side. And then they took 9 divided by 3 to get that 3 there. And so this would be the inverse of this. And so again, we're not going to be looking at the graphs right now, but if you did look at the graphs, they would be reflecting each other. So all the points from the first function to the second function would be flipped. They would be like mirror images of each other. All right, so let's walk through this practice problem together, and then you can try to do the other one on your own. Okay, so as I kind of talk through this, I want you to be either saying out loud to yourself or thinking to yourself, what would you do for the first step, second step, and so on. So what's the first thing that you should do? You should replace f of x with y. Okay, what's the second step you should do? You should switch your x and your y around. So now it's going to say x equals 4y plus 8. Now what do you need to do? You need to now solve for y. So the first thing you're going to do is, instead of having plus 8, we got to move this over here, so we're going to do that by subtracting 8. So I'm going to write minus 8, minus 8. And remember, you want to do that over the equal sign. So it's gone over here. On the left, I'm going to write x minus 8 equals 4y. And now we're going to divide everything by 4. So I'm going to divide both of these things on the left-hand side by a 4. And like I said earlier, I'm going to go ahead and put y first, just because it makes more sense for me to say y equals than to have the equation equals y. And then when you divide over here, remember there's a 1 in front of that x, so it becomes 1/4 x, and then negative 8 divided by 4 would be negative 2, so minus 2. And there's your inverse function. So pause the video, try to do this one as much as you can, and then resume watching when you're ready to see the solution. First thing we're going to do is replace that f of x with a y. Then we're going to switch our x and our y around. Now I need to solve for y. I want to get rid of this minus 3 first, and I'm going to do that by adding it over here to the x. Now I have x plus 3 equals 1 over 5y. Now some of you may have gotten stuck with the fraction. Remember, when you're dealing with fractions, we don't want to divide by a fraction because that gets really complicated. So instead you want to multiply by the reciprocal. So I'm going to take both of these sides times the reciprocal of 1/5, which would be 5 over 1, or just 5. So over here, the 1/5 and the 5 will cancel each other out. They'll become a 1, so you have 1y, or just y. Now on the left-hand side, you need to make sure that you distribute that 5 because you have an x plus 3, so you have to take it times the x and times that plus 3. So it should have said y equals 5x plus 15. So we're going to continue to do the same 3-step process, but we're going to start changing the way that our equations look. So for this next one, we start with this equation, f of x equals x squared plus 7. You can see that they replaced f of x with y. That's step number 1. Step number 2, they switched the x and the y around. So now it says x equals y squared plus 7. And now we need to solve for y. We subtract 7 first, and that's how we get this x minus 7 equals y squared. Now if you think back to section 4 when we were graphing radicals, I had talked to you guys about how a quadratic and a square root are related to each other because a square root function is taking the opposite, like just taking the root of that quadratic there. So to get rid of something squared, you need to square root both sides. So because I have y squared here, I'm going to square root that and the x minus 7. And that's how they got what they wrote right here. So you're going to leave that x minus 7 underneath the square root sign, and you're going to have just a y on the other side now because the square root sign and that squared cancel each other off. And so this is your answer for your inverse. Go ahead and try this one. I would have started by taking y equals x squared minus 18. Now I'm going to switch my x and my y. To solve for y, I'm going to add 18. So now it says x plus 18 equals y squared. And to get rid of that squared, I need to square root both sides. So I should have been left with y equals the square root of x plus 18 for my inverse. This next practice problem is similar, except for the fact that they put parentheses in your problem. And so this whole quantity, the x minus 4, is squared. All of it's squared, not just the x. So I want to walk you guys through this one so that you know how to handle a situation like this one. Still start by replacing that f of x with a y. Now I'm going to switch my x and my y around. So it says x equals y minus 4 squared. Now I can't add the 4 quite yet because I have this parentheses around that whole quantity. So I want to get rid of the squared. So what I'm going to do is square root that entire right side, and I'm going to square root the x. So when I do that, I'm going to have x underneath the square root sign, and you're going to want to leave it like that. And over here on the right, the square root and that exponent are going to cancel each other off, and you're going to be left with that y minus 4 quantity. So all of that's going to come out of the square root. Now, we still don't quite have y by itself, because it still says y minus 4. So I'm going to add 4 over here to the other side. And to write my final answer, again, I'm going to put y first. I'm going to have that square root of x, and then plus 4 is going to come after it. So a little different than what we saw up above, because everything was underneath the square root here, where this one, just the x is underneath the square root, and the 4 is tagged on the end. Now you can do the same thing if you had something raised to the third power. So that's the only difference here, is that you have this x to the third instead of an x squared. The steps are pretty much the same as what we did on the previous page there. I switch that f of x with a y. I change my x and my y around. And then we start our process for solving for y. So I'm going to start by subtracting 11. So it says x minus 11 is equal to that y to the third. And now I cube root both sides. And this time I have to cube root it because it's y to the third power. So you're going to have to put a little 3 in your radical symbol. And so again, just like we saw on the previous page with the square root, except now we have a cubed root, you have that all over the x minus 11. And then your y is just going to come out. And this is going to be your answer for your inverse function. So there are 2 examples, 2 practice problems here. This is the first one, and here's the second one. Go ahead and give those a try, and then keep watching to see how it got solved. So we're going to replace f of x with y. Now we're going to switch our x and our y around. We're going to add 31 to the x. So now it says x plus 31 equals y to the third. And now I'm going to cube root both sides. So my inverse should say y equals the cube root of x plus 31. And all of that is underneath the radical sign. Now moving on to the second one. Again, I'm going to say y equals 2x to the third plus 17. I'm going to switch my x and my y around. I'm going to start by subtracting 17 from the x. So I have x minus 17 equals 2y to the third. I want to get rid of the 2 here, so I'm going to divide both sides by 2, and you could write it like this, a big fraction, or you could do your split fraction like we did on the first couple of examples. So I have x minus 17 over 2 is equal to y to the third, and the last thing that I'm going to need to do here is cube root both sides. So I have y, and then I have this big cubed root of x minus 17 all over 2. And that's your inverse.